Hello and welcome back to TodoItem Blocks. In this Flutter tutorial series, we were building a simple to-do list or notes app that will allow users to add, delete and view items, as you can see on the screen currently. The to-do list items will be stored in an SQL database, so you will learn how to use SQFlight and path related packages. I am assuming that you already have Flutter installed. If not, the first link in the description will take you to the Getting Started guide on the Flutter website, where you can find full installation tutorials and links for your related operating system. Here you can see an overview of the different classes and functions in the app that we'll be making and how they fit together. At the beginning of each new video, I will recap what we made in the previous video and then use this document to show you what part of the app we will be building and how it fits into the overall project. In this video, we will be building the database storage functionality and the data model for the TodoItem. We will be building this section first, as the rest of the project is built around the data added to and read from this database, and we need to allow for the asynchronous features included in this section when building the UI and functionality for the app. The DatabaseProvider class will provide methods to delete items and to get a list of all items along with setting up and or opening the database. The TodoItem class will provide methods used by the DatabaseProvider class to store data in the correct format, and will also be used in the rest of the project to display details about each to-do item. Now we know what we'll be making and why, let's make a new Flutter project and get started. I will be using VS Code, but the process will be much the same if you are using Android Studio or IntelliJ IDEA. So the first thing we need to do is create the new project. To do this, in VS Code we just go to Flutter, in command, and new project. We will call this project TodoApp_YouTube, however you can call it whatever you want. And then choose where you want to save this. I'm just going to save it in my app development folder. And then we wait for Flutter to build the project, and this will take a little while, so I shall come back once it is finished doing it. So we've created the Flutter project, and now we need to navigate to our pubspec.yaml and add in some dependencies, as I have already done here. These dependencies are SQFlight, Path Provider and Path. We will be using SQFlight to manage our database, and Path and Path Provider to store the database in the correct location on the user's device. And we add these like I have done here in the Dependencies section. These are the latest versions of each library at the time of recording. However, there will be links in the description to the pages for each library on the Dart Pub website, where you can find the latest versions along with documentation. For now, we don't need to edit the main.dart file, as we're building out user functionality in later videos in this project. Instead, create a new folder called Data Persistence within the lib folder of your project, which is found here, and we can create a new folder like so, and call this folder Data Persistence. In this folder we will be needing to create two Dart files, TodoItem.dart and DatabaseProvider.dart. We will first work on the TodoItem.dart file, as aspects of this class will be used in the DatabaseProvider class. In this class we need to import Dart convert, as it will be encoding and decoding JSON data. First, we need to create a new class called TodoItem, which is the same name as the file. This class will have four properties: int id, string title, string description, and string priority, which will be the colour that you saw earlier on in the demonstration of what the app will look like. The class also needs a constructor, which we can do in Dart on one line to instantiate all these properties. We can do a constructor like so, and if we put these in the curly brackets, we can have it so when you create a version of this class, it comes up with the labels for each of these properties. Next, we need to create a factory to convert JSON data to a TodoItem. This factory will accept a map string dynamic as an input and return a new TodoItem using the data from the map passed to it. And we can do that like this with the factory tag, and then TodoItem dot from JSON, and this is how you pass data to a function in Dart. And then we're only returning one thing, so we can use this notation, and this will return a new TodoItem with an ID of JSON, and then we want the ID section. So this is just passing some map, which is the JSON value, and we have dynamic to the second part of the map, as we have different properties. So you can have an integer for the ID, all the other properties are currently string. And this is how you instantiate a version of it. And you just need to get the values from the JSON file. Now we need a function we can use to do the opposite, convert a TodoItem to a map. This will return a map using the data from the TodoItem passed to it. And we can do that like this. Once again, we use the map string notation to say what type of data this function will return. And we can call this toJSON as opposed to from JSON. And once again, we can use this notation as we're doing one thing. And this is for creating the map that we've just decoded in the previous one. So you have the tag and then the data value, and then the next tag, and the next data value, and so on. The TodoItem class needs two more functions, TodoItem from JSON and TodoItem to JSON. The former will accept a string and decode the string to JSON data, then return the result of the JSON data being passed to the factory we've just created. And what this essentially is doing is it is creating a TodoItem from the data that's passed to it, which you'll be getting from the database. And do that like that. Once again, we dictate what type of data the function will be receiving. We have the string of JSON data. And this will turn it into the map that we are able to decode using our factory, and these methods are why we needed to import the Dart convert file. And then we just need to return the result of passing it to the factory, which is like so, and pass that JSON data. And that's that function done. And the final function we need to do is the TodoItem to JSON. This will accept a TodoItem and call the toJSON method on it that we created earlier, and then return the JSON encoded version of the data. As the JSON itself is within a string, as we've just found out in the previous bit, but we're creating a map. So to do this, we have a function that returns a string called TodoItem to JSON, and we pass that a TodoItem, and we'll call that data, and then we have a value which will equal data dot to JSON, which we'll call this function here, and then we return JSON dot encode and the value we've created there. And that's it for the TodoItem class. It's now finished, and we can move on to creating the DatabaseProvider class. Okay, so I discovered I actually made a mistake earlier in this video. When adding dependencies, you need to have them in line with this section and not indented too much to be included in Flutter. Once you've done that, run flutter packages get to ensure that we have the necessary packages to use in our file. Now we can actually start using DatabaseProvider.dart and start developing this class. So we need to add our imports for SQFlight, path, pathProvider, Dart.io, Dart.async, and our own class TodoItem which we've just made. So you import the packages like this, which I shall now do for the remainder of the packages we need. Then we also need to add the import for our own class. Now because this is in the same folder, we can use import / to navigate to within the data persistence folder, and then we want to import TodoItem.dart. Once more, we need to create a class and a constructor. However, in this case, we do not need to pass it any values. Using the underscore to signify that we can only use this constructor, to be more precise, within this class. And then what we need to do is we need to create a singleton in this class, which will instantiate the database provider once and provide the only way to access the database, as we do not need more than one version within the app. The next function we need to create is the function to get the database. First we need to provide a database to be got, which you'll call underscore database. And then we create a get function which will return database, which we will then access in later functions within this class. So the future annotation and async show that we are doing asynchronous programming, which means that we can access the SQL database on a separate thread to the one that manages the user interface, to prevent any hang-ups if it's taking too long to access the database. So this is checking if the value we already have exists, then we return that value. If not, we need to assign that value to something, which in this case will be another asynchronous tool, to a method we haven't created yet, but will be called initDB, and then we return that database. So initDB will initialize the database, and it is another asynchronous function. The first thing we need to do in this function, once we've created it, and this again is async like that, is we need to get the application documents directory path. This can be done by using the get application documents directory function. So what this bit of code does is it gets the application documents directory for the user's device, and then allows us to store the database within that documents directory. The next thing we need to do is create the path which we'll be using to store the database in. So this is just a string, and we use the join method to add application directory.path, and the name of our database, in this case it will be todolist.db. And then we just once more need to finish the lines off with the semicolon. And then we return the result of open database, and then within that we execute the function to create the new table. To do this we do return await. We pass the function the path we've just created, a version number, an onOpen function which will pass the value of db and leave empty, and an onCreate function. OnCreate function we will pass a database called which you'll name db in this case, and an int of the version which we've just got in the previous section. This will once more be asynchronous. And within this we call awaitDB, which is the database we're passing to it, which is todolist.db. Execute, and then we need to pass it some SQL statement which will create a table within our database which we want. So to do this, we use create table to-do list and then in brackets ID integer primary key, title text, description text, and priority text, and then we close that statement off. If you don't understand SQL statements, I recommend you look them up before doing more in-depth stuff with SQL, because it's the only one we're going to be using fully in this app. The bit in capitals after the name in brackets, so if your ID, that's of type integer primary key, which the database automatically generates, and all the others are just text values, which is the same as a string within Flutter and Dart. So we just need to close this statement off, and that is the initDB function complete. We need 3 more functions that we'll use to add a new item, delete an item, and to get the complete list of all items. We do not need to provide full CRUD, which is create, read, update, delete capability, as we will be using a different method to access data for individual to-do items, and the app does not currently provide the user with the ability to edit to-do items. First, we will create a function to add a new item. This function will pass an instance of a to-do item class. We will use an instance of the database and call it DB. The database we're accessing here is from this function up here of getDatabase, and then variable which we call res, which is short for response, and then await to this asynchronous, and then we use not raw SQL statements. The sqflight package provides methods to add and edit SQL statements without having the full SQL code. So we just call the insert method, and we pass the name of a table, which we called to-do list, and then values is to-do item, and then we call the toJSON function on it, and then close that off, and then we return res. Next, let's create the function to delete an item. This function will pass the ID of the item to delete. Once more, we create an instance of the database. We don't need to return a response, we just call db.delete, and then once more we pass the name of the table. This time the statement is a bit more complicated as we're doing more. We need to provide a where clause, which will enable us to specify a specific row in the table instead of just deleting everything. This is where ID equals question mark, and then we can provide arguments using the whereas property, and this will be the ID that was passed to it. And that's that function done. The final function we need to create is the getAll function. This will return a type of future list to-do item. Once more, we need to create an instance of the database, and this time we will store a response to querying the table in the value of res, or response. Then in response we need to ensure we have await, so it's returning a list and not a future, because we can't do what we need to do if it's a future. And we just pass query the name of the table. If we wanted to get a specific item, we would use, like we did for the delete function, and pass it the ID of the item we wanted to get. So now we need to return a list, so we can do this using the list.generate function. We need to pass this the length of the response that we got, which we can get using res.length. And generator is our own function that we're going to create, like this. And then for each item we want to return a to-do item, and then pass it the data from res and I, as we're looping through. This is basically like a for loop, but using the list.generate function. And then we pass it each of these as it's a map, and then title will equal res I title, and so on for the other variables, which I shall now do. We can reformat our code by using the Shift-Alt-F command, and that will make it more legible and split it out over multiple lines. So that's it for this video. In the next video we'll be starting to build out the functionality for the app. Feel free to leave feedback on the format of this video in the comments below, as I am still working on improving my tutorial formats to make it as easy to follow and informative as possible, as this is my first tutorial in a long time. All the code for the database, files, and the project in general can be found on GitHub, and I shall leave a link to that below in the description as well. Other than that, I hope this video was useful, and I shall see you in the next video.